In this video, we want to focus on current density. Small letter G is what we use to denote current density. For example, if we have a piece of wire that has a cross-sectional area A and it's experiencing electric field, these are charges. This is the length L. We need to know that the electric current passing through a given cross-sectional area of the wire per unit time is given as I current equals to delta Q over delta T, because Q is equal to IT. This is the charge, that's the quantity of charge passing through a cross-sectional area in time. So because of that, we define current density as electric current per unit cross-sectional area at any point in space. Okay, it is given as this equal to I over A according to the definition, is also equal to the charge and N V D. This is because these charges that move, they move with a particular speed, they drift with a particular speed we call drift velocity, which is this drift velocity. So that is the formula for current density. And the electric force that propels the charges through the conductor as a result of electric field inside is as a result of electric field inside of this wire. For example, this question says if 0.4 millimeter diameter of copper wire carries a current of 3 microampere, find the first one, the current density. Then 2, the drift velocity. So for us to solve, we have that the current density is given as I over A. But in this question, we don't have A. But since we have diameter D, we know that area A is given as pi D squared over 4. Because it is in terms of diameter. So pi is approximately 3.142 blah blah, so we approximate it. Now the diameter is 0.4, but it is in millimeter. We need to convert to meters. If we convert to meters, we will have 0.4 divided by 1000, which is times 10 raised to power minus 3, now in meters squared. So all over 4, and we have to press calculator. So the answer to that area is 12.56 times 10 raised to power minus 8 meter squared area. Now since we've gotten area, we can now find the current density, which is I given to us in the question is 3 microampere, which is 3 times 10 raised to power minus 6, that's ampere, over area is 12.56 times 10 raised to power minus 8 meter squared. If we press calculator, we're going to have 23.89 ampere per meter squared. So the next question is to solve for the electron drift density. Return. Now, since there is one free electron per atom, the density of free atoms N is in the same, like it is the same density of copper atoms. The atomic mass of copper is already 63.5. Therefore, what it means is that 63.5 grams of copper contains Avogadro number, which is 6.02 times 10 raised to power 23. So these are free electrons that are contained here. And when we check in some of physics or chemistry handbooks, we see that the density of copper is about 8.98 times 10 raised to power 3 kilogram per meter cube. So because of that, for us to now get N, the number of charges, because N is the number of charges per unit volume. So for us to get that, it will be the Avogadro number 6.02 times 10 raised to power 23 electrons over, this is already in grams. For us to put it in kilograms, we have to put it divide by 1000, which is 63.5 times 10 raised to power minus 3. So it becomes in the inner is in kilogram. So we can now multiply by the density of copper, which is 8.89 times 10 raised to power 3. So okay, let's still add the value, the units, which is kg per meter cubed. And if we press the calculator, we'll have 8.43 times 10 raised to power 28 electrons per meter cubed. Because of this, remember our formula for electron density, for current density. We said current density is equal to I over A, but it is also equal to the relationship it has with velocity drift. So from here, if we make velocity drift the subject of the formula, Vd becomes equal to J becomes on top over NQ. So our J, as we've calculated before, is about 23.89. Then N, as we have calculated above, is 8.43 times 10 raised to power 28. Then times the Q, the charge of electron is 1.6 times 10 raised to power minus 19 coulomb. So if we press the calculator, we're going to get 1.77 times 10 raised to power 9 meters per second. That will be the speed because of velocity, meters per second. Please do well to subscribe to my channel if you haven't. Thank you.